Morning. So this morning we're going to talk about a ancient building. It's actually not that ancient, but it's sort of about 1,000 years old, and it is called the Leaning Tower of Pisa. And Leaning Tower of Pisa is this messed up tower made of marble in Italy, in a tiny town, small town called Pisa. It's on the Mediterranean coast. Quite a beautiful place. I haven't been there, but I'd love to go. This tower was built about, I guess, 900 years ago or so. And you'll notice a flaw in the design. And the really ridiculous part about this tower is that Pisa is actually a word that means, I believe it means swampy land or swamp. So you can sort of understand what happened when they started building this. So when they started building this tower, they built it on a foundation that was not as solid as it needed to be, and marble is very heavy. And so as they're building this tower 1,000 years ago, it slowly started to lean more and more, and they ended up with this crazy tower that now ironically has become this major world attraction. People go to see it just because it's sort of bizarre. And you sort of think, well, it's going to fall on this thing, like it's going to fall over, but it hasn't, and it's almost 1,000 years old. So um, at this point, they've put in a lot of structural supports to try and keep it from falling over. They've injected some sort of stuff in the foundation to make it more solid, to make sure it doesn't fall over. Because if it fell over, it would be a historical catastrophe. But I want to talk a little bit about the Leaning Tower of Pisa because the idea of architecture has got a lot to do with angles. We've talked a little bit about already about, looking at your house and finding angles and shapes and geometry in your house. Well, angles are very important when it comes to architecture, and I'll explain why. Oh, so first I was going to show you where Pisa is. It's right here. In fact, we can go on a little tour. Let me just take you on a quick tour of Pisa here. So there's Pisa there. Zoom in a little bit at what it looks like. I'm going to drop my little guy here right beside. Actually, maybe I'll zoom in more so we can make sure that we're actually close to where we want to be. There's the town. There's the tower. So I'm going to drop him right there. Oh, there's a market. Oh my, I don't know where I am. Okay, let's get a little closer here. Okay, I need to get closer to the tower so that I know that I'm actually, there it is. Drop my little guy here instead. That's better. So there it is. And you can see, I mean, that it's definitely on an angle. It's spectacular building beside it, but you see there's a lot of people that are coming to see it. I'm going to get a little closer here. Sort of cool. There it is. You can see it's leaning quite a lot. And lots of people coming in to see it. Now, you used to be able to go in, there's a spiral staircase in the middle of it that you could go all the way to the top. And it was actually built as a bell tower for a bell. When it was built, it was quite a spectacular achievement when it was built. It sort of reminds me, if you can see that it's got some Roman architecture in here with the pillars and the archways, and we'll talk a little bit about that when we look at the Roman ancient civilizations. But the flaw, of course, so the problem in this tower is that architects discovered or realized very quickly in building buildings, and you've noticed this yourself, I'm sure, is that you've probably taken it for granted, is that everything that is built in order for it to stand over a long period of time must be perpendicular to the Earth's surface. And what perpendicular means is coming straight up from the Earth's surface. So the Earth's surface goes this way, it's called horizontal. Every building must be perpendicular to the Earth's surface. Now, of course, there are exceptions like the Leaning Tower of Pisa or buildings that are built intentionally to lean, or perhaps like the ancient pyramids. But even the ancient pyramids, the center of the building must be perpendicular. If you draw a line from the tip to the middle, it's going to be perpendicular. The weight of the building is balanced. So in your house, your walls are perpendicular, towers are perpendicular, phone poles are perpendicular. Perpendicular is another fancy way of saying 90 degrees from the Earth's crust. So that is a 90-degree angle. Remember we talked about angles and how things are done in angles. And when people started building things and realizing they had to be 90 degrees in order to stay over, they didn't come up with 90 degrees. Mathematicians and architects thought, well, let's measure. We have to have a measurement ability, a measurement of this angle. And the way you can tell 90 degrees is that its gravity always pulls to the earth at 90 degrees. So no matter what you hold, if you drop it, it drops perpendicular to the earth's surface. So they knew that if, well, let's call this 90, and then we'll measure all of the degrees based on that. So we're going to divide this line and the difference between the two into 90 measurements or 90 units. And then the rest of the measurements, further or less, we'll be able to compare that to the 90 and then understand what they are. So the Leaning Tower of Pisa should be 90 degrees in order to stand. So what they thought was, okay, well, if perpendicular is 90, that's 90, then, well, that makes sense that the opposite side would be 90. And it makes sense that if I go another sort of L shape, it'd be 90, and another L shape, it'd be 90. So that's how they came up with 360 degrees all the way around in an angle. So 90 plus 90 plus 90 plus 90 is 360. So the Leaning Tower of Pisa, in fact, should be this straight. It leans approximately 4 degrees. Now, this actually looks like way more than 4 degrees, but I think it's just the angle that the picture was taken. But 4 degrees is what the angle is from that it's off, right? So it should be at 90. It's like at 86. It's a little bit off, right? So when we look and talk about angles, 90 degrees is the most important angle that we know. Okay, so it's one of the ones that is something we compare things to, and it's really based on architecture, the way things are built. I have actually a special tool. It's got a weight on it with a string, and if I am building something and I want to make sure that it's 90 degrees, I hold the top of the string and let the weight dangle down, and it will be at a 90-degree angle, and I can look at the string and test if something is 90 degrees to make sure. I also have something called a square, which is a metal 90-degree bracket with centimeter measurements on it, and that is another tool for people who do construction. And I mean, your parents probably have one in their basement, maybe. And it is a 90-degree angle, and it's just used for making corners when you're doing construction. So it's actually quite useful. So when we talk about angles, we talk about the 90-degree angle as being one of our benchmark angles. It is an angle that we recognize just by looking at it. So it's when it's studying angles, it is helpful if we understand and recognize benchmark angles so we can estimate angles. So benchmarks are angles that we recognize just by looking at them. So there are some that are very helpful, and these are the ones that are the most helpful. So there's the 90-degree one, and then down here, it's half of this. So if I drag this one up, you can see that it's about half. It's if this was a square, that line would be going from one corner to the other corner. So that, in fact, is a 45-degree angle. This one. Oh, and by the way, this is the little symbol for degree. This little baby circle, that means 90 degrees. Instead of writing out degrees, that's what we do. This one is bigger than this one, and it's about 2/3 of the way up this one. This is a 60-degree angle. And this one, you'll notice, is about half of this one. That is a 30-degree angle. So those are the 4 benchmark angles we're going to be learning about this year. It's 90, 60, 45, and 30. And they are very significant angles. You'll notice that they all divide very easily into 90. Well, 60 doesn't, but it's sort of a step there. So if we divide 90 in half, we get 45. If we divide 90 into thirds, we get 30 and 60 and then 90. So those are sort of the benchmark angles we're looking at. And the assignment that I'm giving you today is basically just trying to figure out which one of these angles is in fact this number. So remember these benchmarks: 90, 60, 30, 45. You're going to need to know that. And then there's a couple of angles that I'm going to give you that are not quite one of these. I want you to guess what you think the angle might be. So if it's a little bit more than 90, well, then maybe it's 94. If it's a little bit less than 45, maybe it's 35. 5. All right, so keep that in mind. And that's all the work for math for today.